All right, so we're looking at the first part of the 7.1 homework here. So we're going to be solving systems. So a lot of these are going to be kind of redundant, so we'll just do a couple from each little section. So this says solve the system of equations by graphing, but it doesn't actually give us a graph. So you can use graph paper to do it. You just want to make sure that you're using graph paper so that you can see where the boxes are. Otherwise, we could just solve this in a different way. So if we were going to solve it by graphing, though, you'd want to, this isn't going to be very good. So the first one crosses the axis at -5. So 1, 2, 3, 4, 5. And it has a slope of -6, which means we can rise 6 and go back 1. So we've got this point, and then we have to connect them with a perfectly straight line. This is why you really need graph paper. So for the next one, it crosses the axis at -1, has a slope of -2. So I'm going to drop 2 and run 1. And it looks like that. So see, I can't really tell where they're going to intersect. So I'm going to do it a different way just because I don't have graph paper. I'm going to use substitution. So this first one says that y is equal to -6x minus 5. So I'm just going to plug that in for the y in the second one. So -6x minus 5 is equal to -2x minus 1. So it says y is equal to -6x minus 5, but also y is equal to -2x minus 1. So those two things have to be equal to each other. So now I'm just going to add the 6x to this side, and I'm going to add the 1 to this side, and then we'll divide both sides by 4, and we see that x is -1. So that's actually, see, supposed to be at -1, my intersection. And so now you can plug that -1 into either of the originals. It doesn't matter. I'm just going to plug it into the first one. So -6 times -1 minus 5. So I'm just plugging in a -1 for the x. So notice that's going to give you a +6 minus 5, which is a 1. So that intersection is actually supposed to be right there. So -1, 1 is our intersection point. So -1, 1. So we'll just put that in there and not worry about iTunes. All right, so the second one's going to be the same type of question. So let's just go to number 3. So in number 3, it says solve the system of equations. Again, it says by graphing. But this one might not have a solution, or it might have an infinite number of solutions. So or it might have a unique solution. So remember, those are the 3 choices. These are linear. So if the lines turn out to be parallel, then notice they never intersect, so there's no solution. So if they're parallel, there's not going to be a solution, and we call this inconsistent. Or the lines are going to intersect, like the last one, at exactly one place, in which case there's a unique solution, and we would say that it's consistent. Now, the other option is that the 2 lines are actually the same line. So if they're the same line, then there's an infinite number of solutions, because every point on the line is on both lines. So infinite number of solutions, and we say that the system is dependent. So these are the 3 things that could happen. So let's see what happens in this one. We can solve it. It doesn't really matter. I'm going to use substitution again. So I'm going to take the second one, and I'm going to solve it for y, just because it was really easy just to move the 3x over. I guess I could have moved the 15 over on the first one. But so I solved this one for y, and now, so y is equal to this, so I'm just going to plug that in for that y. So 1 minus 3x plus 15 equals 5x. So now I'm going to add the 3x over to this side. And 1 plus 15 is 16. So now we'll divide both sides by 8. and we get that x is equal to 2. So it looks like our x is definitely going to be 2. So now what we're going to do is just plug that in to either equation. Actually, there's 3 here. I'm going to plug it to the one that I had solved for y. So y is equal to 1 minus 3 times x, which means 1 minus 6, which is negative 5. So that gives me the solution to negative 5. Now, if you hadn't gotten a solution, the no solution, you're going to end up, you try to solve and you'll end up with something like 2 equals 0, which is not true, okay? So then you would have no solution. We just did a unique solution. The infinite number of solutions, what would happen is as you started to solve, you'd get something like 3 equals 3, which is always true. So that means there's an infinite number of solutions. But for this one, we're just going to do 2, negative 5. And then also remember, you can plug these in and check them. So like if I plugged that into the first one, I'd have negative 5 plus 15, which is 10. And 5 times 2 is also 10. So we could see that it was equal. So, darn it, I just forgot. Was it 2, negative 5? Yay. And so make sure you read the directions. It says if it was inconsistent, it says put DNE in each box. So you'll put DNE here and DNE here. If it's dependent, you're going to put, that means there's an infinite number, you would put infinity in both boxes. And you can do double O to get the infinity, or there is the symbol right there, and there's the DNE. So see, if it had been dependent, you would have put this as your answer. If it had been the other, then you could have just put the DNE. So, yes. All right, so the next one is the same type of question. How about we do number 5? So, same question as the last one. I just want to see if we get one that's not perfect. Let's see. And again, we can do this in any number of ways. I'm just going to do substitution again. I just like substitution. So I'm just going to move the 15 over on the first one. So see, I just moved the 15 to the other side. So now y is equal to this. So I'm going to plug it into the other equation for y. So 5x minus 15 plus 4x equals 3. So notice this one, we're going to get a unique answer again. 5x plus 4x is 9x. And then I move the 15 to the other side. Divide both sides by 9, and I get that x is 2. And so then I'm just going to plug it into where I'd already solved. So y equals 5 times 2 minus 15, which is negative 5. Oh, was that the same question as last time? So 2, negative 5. Look at there. So I'm not going to bother with that. Okay, so let's just keep moving. All right, so this one, let's see if we are actually, yeah, okay. So this is another solve by graphing, but we're actually going to graph it, you guys. So we've got our grid here for graphing. So for the first one, it says negative 2x plus 1. That means it crosses the y-axis at 1 and has a slope of negative 2. So I'm just going to make sure I've got the line picked, and I'm going to put a dot at 1, or a point at 1, and then we want to drop 2, run 1. Notice this is decreasing, which it should be because we have a negative slope. So there's the first one. So now we want to make sure line is still picked, and we're going to graph this second one. So the second one crosses the axis at negative 4 and has a slope of 1/2. That means up 1 over 2. And looky there. We can see our intersection point beautifully. So our intersection here is right there. So what is that actual point? Well, the x value is 2, and the y value is negative 3. So this is the point 2, negative 3. And again, you could check that if you wanted to. If you plugged a 2 in to the first one, you'd get negative 4 plus 1, which is negative 3. Yay. And if you plug a 2 into this second one, you'd get 1 minus 4, which is also negative 3. So you can always check, so that's good. So our answer here is going to be 2, negative 3. And let's see, I'm guessing we're going to enter it as an ordered pair. So 2, comma, negative 3. See how we did. Oh, yeah, we got it. All right, so When it comes to graphing, again, those first ones say to graph, but it's a little difficult to graph without actual graphing paper. So I'm guessing 7 and 8 are probably the same. Let's look at 8 just for the heck of it. So in number 8, it's not actually solved for us where we can, well, the second one's not anyway. So before we go to graph it, let's just fix that first one. So I'm just going to solve this one for y so I can get this, the intercept and the slope out of it. So 8y is equal to, I'm moving this to the other side. Now I'm going to divide everybody by 8. So we have that y is equal to -1/2 x plus 2. So that's going to tell me what my slope is and what my intercept is. So this one's gonna, I'm just gonna write this down because it's gonna go away in a second. So -1/2 x plus 2 for that second one. So let's just go ahead and graph these two. So the first one, make sure your line is picked. First one crosses the axis at -4 and has a slope of -2. So we would drop 2 and run 1. So there's our first line. For the second one, remember we had solved it and it crossed the axis at 2 and had a slope of -1/2. So that's drop 1, run 2, which will put us right there. And so, oh, that is not a good intersection point. Let me just check myself. So we crossed at -4 and we have a slope of -2. So drop 2, run 1. So that looks perfect. And then the second one, let's see, it was -4/8. So that's -1/2. That's drop 1, run 2, and it crossed the axis at 16 divided by 8. Okay, you guys, I hate it when it's not like perfect. Should we just kind of guess at it? How about -3 point, oh, 3/4 of the way down. So -3.75, comma, and it looks like it might go up 3.75. I bet it's going to say this is wrong. So I hate it when it's not perfect. So let's see what we get. It didn't like my point. So let's see what the point should be. Oh, that is not at -4/4. So I guess so here's what we've learned from this. I don't know what make the points look better. Here, let's try another one. Or let's try this one again. All right, so I'm gonna graph it again. I'm just gonna make sure that I'm real careful. So -4, make sure I'm right on -4. And then the slope was -2. So I'm gonna rise 2 and go backwards 1. I'm just gonna make sure that is right on there. Okay. Now for the second one, we crossed at 2. I'm just gonna make sure I'm right on there. And it was -1/2. Let's make sure he's right on there. And looky there, now I can see -4/4. So, so I just didn't graph careful enough. So you guys be careful, make sure that you're that you're right on those points when you go to graph it. So it liked my graph, even though the graph wasn't perfect. And see, even now it's not quite on -4/4, but your answer will be a nice number. So just if it's not right on there, just play with it a little so you can get it right on there. And we just have more of the same, you guys. This one's specifying to use the substitution method. So remember, the substitution is the one that I've been using. Solve one of the equations for one of the variables. And look, this one's already solved for y. And plug that into the equation. So x plus 5x equals 42, which means 6x is 42. So we'll divide both sides by 6, and x must be, what is that, 7? So now that you have that, just plug it back into either equation. I'm just going to plug it into the one that's already solved for y. So y is equal to 5x, which is 35. So our point then is 735. All right, let's look at another one of those. These all say they want me to use substitution, so I'm guessing they're all pretty much the same. Now, let's look at this one. Nothing's solved in this one. So for that first step in substitution, you have 4 choices. We could solve the first one for x or the first one for y. We could solve the second one for x or the second one for y. But as I'm looking at this, it seems like it'd be easiest to solve for that x, because otherwise we're going to have to divide and end up with fractions. So from the first one, we see that x must be -4 plus 5y. So you see it solves nicely for x. So now I'm just going to plug this in for that x right there. So be careful to use parentheses here. So I'm just plugging that straight in for the x. So 5 times that plus 4y equals -1. So I'm going to distribute this all the way through. And then let's add those together. So 25 plus 4 is 29y. And then I'm adding 20 to both sides. So that's equal to 19. So now we're going to divide, and it's not a real pretty number, is it? Y is equal to 19 over 29. So now that we have our y, we can plug it back in, and I'm just going to plug it in where we had already solved for x. So x is equal to -4 plus 5 times 19 over 29. This is not pretty at all. Would be -4 plus, let's see, 19 times 5 is 95 over 29. And getting a common denominator, I'm just going to multiply that -4 times 29. So -116 over 29 plus 95 over 29 is going to give me -21 over 29. Now let me just make sure I didn't mess something up here. So 5 times -4 is -20. 5 times 5 is 25. And then plus 4y. Okay, so I wrote it correctly. So here's my answer. Again, it's not the prettiest, but you could always plug it in and make sure. So like 5 times -21 over 29 plus 4 times 19 over 29 is equal to -1. So I just plugged it into that second equation, and it was right. So make sure you put these in order. So x is -21 over 29, and y is 19 over 29. So that one wasn't the prettiest, but there's our -21 over 29 and our 19 over 29. All right, so let's do ones that says to use addition, and one of them says hardest. It's got fractions. So it says solve using the addition method. So with the addition method, what you try to do is get the coefficients either in front of the x or in front of the y to be opposites of each other. So you've got several options here. We're going to go with x. So right now, one of the x's has a -2 and the other one has a 3. So they're opposite signs, but they also have to be opposite numbers. So we're allowed to multiply things. So if you have a 2 and a 3, then the least common multiple here would be 6. So we want to try to rewrite both of these in terms of 6. So notice I'll have to multiply that one by 3, and I'll have to multiply that one by 2. So what we're going to do is multiply the first equation by 3. So that would give me -6x plus 12y equals 6. So see, I'm just multiplying the entire equation by 3. So -3 times 2, -6, 12. All right. Now the second one I'm going to multiply by 2. And if they hadn't already been opposite signs, then we would have multiplied one of these by a negative. But notice now we get 6x plus 12y. Oh, 2 times 3 is 6. 2 times 6 is 12. Oh, look what's going to happen, you guys. Maybe I should have noticed this. Oh, never mind. It's not as exciting as I thought. All right, equals 2. And so now just add these together, like literally add them together. So negative 6x plus 6x is 0, which was what we were going for. 12y plus 12y is 24y. 6 plus 2 is 8. Now we'll divide both sides by 24. That y is equal to, and that would be 1/3, right? So we can go ahead and reduce that one. So now that I have my y value, I have to find the x. And you can plug that back in anywhere. There's like 4 equations on this page right now where I could put that. I'm just going to put it in, I don't know, how about the second one? I'm going to put it right here. I picked that because the 6 and the 3 will cancel. So we're going to have 3x 6 times 1/3 equals 1. So that means that 3x plus 2 is equal to 1. So subtract 2 from both sides, and then we'll divide by 3, and we have our point. So negative 1/3, positive 1/3. So beautiful. So that really wasn't that bad with the fractions, but so let's go ahead and put that in. So we're going to have, oh darn it, was that the right order? I think that was the right order. So our x was negative 1/3 and our y was positive 1/3. So it looks good. So that is your 7.1a homework. Now let's take a look at the 7.1b homework and see what that looks like. All right, so this is, well, more solving. We did lots and lots of them, but this one has some more word problems in it. So these first ones are just like all the ones we've been doing. They just have the boxes separate for the x and the y, but it doesn't specify how to solve. So we're just being really redundant. You guys are going to do a lot of solving. This number 4, it looks like is going to have fractions in its answer. No big deal. All right, so let's do one of the word problems. All right. So looking at this first one, it says Demetrius is 2 years older than Ashley. In 4 years, the sum of their ages will be 72. So how old is Demetrius now? So first off, we have to come up with variables. So I'm going to let D be Demetrius's age. And I'm going to let A be Ashley's age. All right, so it says Demetrius is 2 years older than Ashley. So Demetrius is 2 years older than Ashley. Okay, so if Ashley was 5, then Demetrius is 7. That makes sense? So here's an equation. Notice, I forgot to mention this, we have 2 things we don't know about, so we need to have 2 equations. If there were 3 things we didn't know, we would need 3 equations. You always have to have the same number of equations as unknowns, at least. So we have an equation. We have 1 equation so far. The second part is going to tell us the second one, the second equation. It says in 4 years, the sum of their ages will be 72. So let me just alter this just real quick. Demetrius' age now, Ashley's age now. So right now, this is our D and this is our A. So this says in 4 years, the sum of their ages will be 72. So I would take Demetrius's age now and add 4. So this would be how old he is 4 years from now. Take Ashley's age and add 4. This is how old Ashley will be 4 years from now. So 4 years from now, the sum of their ages will be 72. So you see that? So we're going to take how old Demetrius is now, add 4, so that's in 4 years how old he is. In 4 years how old Ashley is. And if we add those together, it should be 72. So now we can solve. I'm going to go ahead and simplify this second one real quick. So this is D plus A plus 4 plus 4 is 8. So in other words, D plus A is equal to 72 minus 8, which is 64. So now I have 2 equations. And this is just like the ones we've been doing. So I'm just going to use substitution because I always do. I just like substitution. So D is 2 plus A, so let's just plug that in for the D there. So 2 plus A should equal 64. So 2 A's should equal 62. So see, I just A plus A is 2A. Subtract that. And now we'll divide both sides by 2. So half of 62 is 31. So Ashley must be 31 years old. Well, Demetrius is 2 years older than her, so he must be 33. So let's just make sure that these make sense. So first off, do I have that Demetrius is 2 years older? Yes, I do. In 4 years, Ashley will be 35 and Demetrius will be 37. And is that going to add up to 72? Yes, it is. So it looks good. So we've got Ashley at 31 and Demetrius at 33. And oh, so it just asked about Demetrius. So he's 33. Yay. All right, let's look at another one. All right, this is commission, I guess. It says you are offered 2 different sales jobs. The first company offers a straight commission of 7% of sales. The second company offers a salary of $250 per week, plus you get 4% of your sales. So how much would you have to sell in a week in order for the straight commission offer to be at least as good? All right, so first off, we need something that represents the first company, something that represents the second company. I'm going to do, I don't know, should we just do X and Y? So we'll let X be sales at first company. Because you see, our question is how much would you have to sell? So we want our variables to represent sales. So that would be sales at, or not, I'm sorry. X is going to represent sales. So let me change this a little bit. I think we can do this without. So if we look at his pay from the first company, based on sales, he gets 7% of his sales, just flat out. So however much he sells, he's going to get 7%. The second company, so his pay at the second company is going to be $250 per week. So we're thinking about this weekly now. And it does say in a week. So 250 plus he gets 4% of his sales. So this actually has the same variable. So I guess we're saying, yeah, it's not really as, I guess we've got 2 equations here. So here's 2 equations, and I want them to be equal. So it says, how much would he have to sell in order for the commission one to be at least as good as the other? So that means, like, where would they be equal to each other? So we're just going to set these equal to each other. So 0.07x equals 250 plus 0.04x. All right, so I'm just going to solve this. I'm going to subtract that 0.04 from both sides. And then we'll divide both sides. So let's divide both sides by 0.03. And 250 divided by 0.03 is, darn it, not a nice one. It's $8,333.33. Now, does it say how we should put our answer in? So notice his sales then, so we can check that number. Should we just say, let's just round it to a whole number maybe? So let's try 8,333. All right. So if he sells 7% or sells that much and gets 7% of it, he would end up with $583.31. That's at the first company. At the second company, he would only get 4% of that amount, but then he'd get $250 tacked on, which would be $583.32. So this is kind of the number we're looking for. It doesn't say which way to round it. I'm just gonna try a whole number. So 8333. Actually, we'll just go answer. Oh, well, we're not gonna type that in. Let's just see what would happen if we rounded it to the whole number. And we got it. All right, so I just rounded it to the whole number. So we do have two equations, but then we're just setting the equations equal to each other. All right, let's look at the next one. Number of coins based on value. All right, so it says a man has 23 total coins in his pocket. All of them are dimes and quarters. So it looks like we are going to let D be the number of dimes, and we'll let Q be the number of quarters. All right, so we need to come up with two equations. Right here it says there's 23 coins in his pocket, so D plus Q must equal 23. Then it says that, oops, meant to highlight that, not cross it out. Then it says the total value of his change is 500 cents, which sounds a little funny, but notice this in terms of cents. So a dime is worth 10 cents. So we have 10 for each dime, plus a quarter is 25 cents, so 25 for each quarter, and we need this to equal 500 cents. So two equations, two unknowns. Now we just have to solve. So let's use addition just because I haven't done addition very much. So let's say we wanted to get these coefficients to be opposites of each other. I would just need to multiply the first equation by -10. So let's just do that. Multiply everybody by -10. So -10D minus 10Q equals -230. So see, I just multiplied everybody by -10. And then I'm just going to line these up. So here's the second one. And we're just going to add them together. So notice my dimes cancel. We got 15Q equals 270. And so then we just have 270 divided by 15, which is 18. So I have 18 quarters, and I know that there's 23 total, so I must have 5 dimes. So we can add those together. 5 plus 18 is definitely 23. If he's got 50 cents in dimes, and 18 times 25 would be 450 cents in quarters. So it looks perfect. So he's got 5 dimes and 18 quarters. So 5 dimes, 18 quarters. We're going to do all of these. This next one is going to be just like that last one, except it's tickets this time. So you're going to, instead of dimes and quarters, you have children and adults. So they're going to have to, children plus adults are going to equal 367. And then 1.5C plus 4A is going to equal 988. So see, it's very similar to the dimes and quarters. It's just instead of dimes and quarters, you have children and adults. Let's see. Let's do this one because you have one similar to this on your worksheet and maybe on your exam. So it says, a man flies a small airplane from Fargo to Bismarck, North Dakota, a distance of 180 miles. Because he is flying into a headwind, the trip takes him 2 hours. On the way back, the wind is still blowing at the same speed, so the return trip takes only 1 hour and 12 minutes. And it says, what is his speed in still air and how fast is the wind blowing? So we have two unknowns here. We have How about W for the wind speed? And I don't know, he's flying an airplane. How about A for the airplane speed? So if it was still, we would just be going as fast as the airplane. Okay, so this is his speed, you see. So his speed is going to be A, the wind speed is going to be W. So if we take how fast he was going and we subtract the wind speed, then it's going to take him 2 hours to go that 180 miles. Okay, so we're going a total of 180 miles. So imagine if there was no wind whatsoever. If I told you it took me 2 hours to go 180 miles, what would you tell me my speed was? Well, speed is distance, miles per hour. So speed is distance over time, right? So I know that flying with it, my total speed was, I went 180 miles and it took me 2 hours. So that's 90 miles per hour was my speed. But that was with the airplane minus the wind speed. I was going 90 miles an hour, okay? He went 180 miles in 2 hours. So he was going 90 miles an hour, but he was flying into the wind, which means the wind was slowing him down. So his speed minus the wind gives you 90 miles per hour. Now on the way back, it took him 1 hour and 12 minutes. So, darn it, now I kind of want to. So 1 hour, 12 minutes. We've got to convert this to just hours. So that would be 1 hour, 12 minutes would be 12/60ths of an hour. I think it might have been easier to convert over to minutes, you guys. Should we do that instead? We'll leave. All right, so 12 divided by 60 is 0.2. So on the way back, he was flying with the wind. Still went 180 miles, but it only took him 1.2 hours. You know what, just for the heck of it, instead of putting the 90 there now, I'm going to put 180 divided by 2. So this was distance. It took him, he went 180 miles, took him 2 hours. The second time he went 180 miles and it took him 1.2 hours, which is 1 hour and 12 minutes. So now we've got the two equations. We can just add them together, you guys. And they're actually all they're set up already just to add together. Because notice the W's are opposites of each other. So if I just add these, A plus A is 2A. And then the 180 over 2 we knew was 90. So this is a 90. 180 over 1.2 is 150. So now add those together and we get 240. So now we'll divide both sides by 2. And we see that the airplane itself was going 120 miles per hour. So how fast was the wind going? Well, if you can use either of these, but let's just think about that one. I don't know. If you put a 120 in there, 120 minus the wind should be 90. So the wind must be 30. So if you add them together, you get 150. If you subtract them, you get 90. So the airplane was going 120 miles per hour. The wind was going 30 miles per hour. Now, the only thing is I kept with hours just because I figured miles per hour is what they want. So let's put in 120 and 30. It really should specify, but that's why we're doing this, huh? So make sure you put your answers in miles per hour, you guys, when you do this one. Miles per hour. right, let's see. Simple interest. We did one just like this in class, I believe. Yeah, we did one exactly like this in class. Let's go ahead and we'll go ahead and look at it. So it says a man invests his savings into two accounts, one paying 6% and the other paying 10% simple interest per year. So I'm just going to call this one the X account, and I'll call this one the Y account. But this is actually going to represent the money, not dollar. I said money and then I put a number sign. So this is the money in that account. This is going to represent the money in the other account. So it says he puts twice as much in the lower yielding account because it's less risky. So whatever X is the less risky one, it's twice what he put into Y. Okay, so Y is the more risky one. So let's say he put 10 bucks in there. Well, that means he put 20 in the X account. So X is equal to 2Y. There's one equation. The second equation is going to come from his interest. It says his annual interest is $6,116. So now this is nice, simple interest. So he gets 6% of whatever he put into that account. He gets 10% of whatever he put into this account. And if you add those together, it should be $6,116. So see, I have two equations, two unknowns. So I am going to use substitution here. So it says X equals 2Y. So I'm just going to plug that right in for this X value. So 0.06 times 2Y plus 0.10 equals 6116. So 0.06 times 2 is going to be 0.12. And if we add those together, we're going to get 0.22. And now we'll just divide both sides. So 6116 divided by 0.22. Holy cow, $27,800. So that was in the higher risk one. That's the W one. So, or sorry, the Y one. So it says he put twice that in the other account. So the X account must have $55,600 in it. Okay. So notice if you go back and read it, he has twice as much in the lower yielding one. Okay. I do have twice as much there. And it says his annual interest was $6,116. So he gets 6% of that 55600. And then he gets 10%. I'm just checking. I always like to check. So 10% of that would leave him with $6,116. So perfect. So let's just put these in. So we got 55,600 and 27,800. All right, let's see. Cell phone plans, number of ticket types. This is the same as that last one, which is the same as the money. There's another simple interest story. Let's look at the cell phone one. So this says you're choosing between two different cell phone plans. Okay, so this one is similar to the guy and his sales, his commission. So the first plan, so plan number one, charges a rate of 24 cents per minute. So you're going to be paying 24 cents for every minute you use. So we'll let X be the number of minutes. So plan one, this is how much you're going to pay. The second plan charges a monthly fee of $49.95. So no matter what, okay, now be careful. I'm going to have to go and change this one. That 24 was in cents, but of course I'm not going to put this one in cents. Well, I guess we could put 4,995, but make sure you're all in cents or you're all in dollars. So I'm changing mine to $2. Plus, he has to pay 12 cents per minute. So how many minutes would you have to use in order for the second plan to be better? So see, if they just said, yeah, you only have to pay 12 cents per minute, you might be like, well, that's half the other one. But if you use, but then you have to pay that $50 fee. So anyway, which, depending on how many minutes you use per month, you can decide kind of which one you want to do. So where are they actually equal to each other is what you want to know, because anything over that, then you'll prefer one to the other. Anything less than that, you'll prefer one to the other. So we want to figure out when are these two plans equal. So we're just going to set them equal to each other. So I'm just going to move the 0.12 over here. I subtracted. They just happened to come out nicely. And then we're going to divide both sides by 0.12. So 49.95 divided by, now again, that 0.12 is from subtracting. I didn't just like throw anything out. So this is 416.25. So at 416 minutes, the first plan is going to cost you $99.84. So I'm just thinking about rounding it to a whole number. So if you talk 416 minutes, the first one's going to cost you this much. And the second one is going to cost you $99.87. Okay, so anything over that, the top one's adding another 24 cents, whereas the bottom one's just adding 12. So this is kind of your second plan is better when you go over 416 minutes. And that's the question. So how many minutes would you have to use in a month for the second plan to be preferable? And we're going to 416. So we're just going to put in 416. I wonder if this has it. Now, I bet we can just put 416. Let's see. All right, so just round it to the whole number of minutes. And then again, the others are all repeats. So you've already seen those. When you do these ticket types, remember, it's just like the dimes and quarters, right? So that's it.